Objective: to understand the discovery of radioactivity. In 1896, Henri Becquerel, a French physicist, while working on the phenomenon of fluorescence, accidentally discovered a new phenomenon called radioactivity. Various minerals that were required for his studies remained untouched for a long period of time. These minerals were put away in a box, along with several sealed boxes of photographic plates wrapped in thick black paper. When Becquerel used one of the plates during the course of his research, he found them to be badly fogged, as if they were exposed to sunlight. He was surprised to see the other plates in the box also damaged. Becquerel had no clue as to how this had happened, so he conducted some experiments to get to the bottom of this. He used two light-tight boxes to store the materials he had. In one of the boxes he stored one of the minerals, pitchblende, along with some uranium ore and a photographic plate. The uranium ore and the photographic plate were kept in contact with each other in that box. In the other box he used the same materials but separated them using thin sheets of aluminium. The photographic plates in both boxes were found to be affected. He then ascertained that it was due to the radiation emitted by the uranium ore. To check if sunlight had any influence on the action of uranium, Becquerel performed the experiment in the presence of sunlight. He inferred that uranium ore was unaffected by sunlight. During the process of his research with different compounds of uranium, he found that irrespective of the chemical and physical conditions, such as temperature and pressure, uranium continued to emit radiation. These newly discovered radiations were called Becquerel rays. Subsequently, the phenomenon was called radioactivity. Elements with atomic number greater than 83 were observed to emit such radiations. The nuclei of the radioactive substances are generally unstable and can undergo an internal change, ejecting particles and electromagnetic radiation. So, radioactivity can be defined as a self-disintegrating, spontaneous activity that takes place in some unstable nuclei that results in the emission of radiations. Radioactivity is a nuclear phenomenon, and the radiations can easily penetrate through thick substances. Radioactive substances usually emit three types of radiation: alpha radiation, beta radiation, and gamma radiation. A small quantity of radioactive material is placed in a deep cavity of a thick lead block. This arrangement ensures that the radiation coming out of the cavity is in the form of a narrow beam. The lead block ensures that radiations coming in from other directions are absorbed. When a strong magnetic field is applied at right angles to the beam, it splits into three distinct components. The radiation that is deflected to the left is made up of positively charged radiations called alpha radiation. They are made up of alpha particles. The radiation deflected to the right are negatively charged beta radiations or beta particles. And the ones which pass undeflected are neutral and called gamma rays. Similarly, when an electric field is applied, alpha and beta radiations are found to bend towards the negative and positive plates respectively. Gamma rays, on the other hand, are found to continue in their path, unaffected by the electric field. An alpha particle consists of 2 protons and 2 neutrons, identical to the helium atom, which is double ionized. The mass of an alpha particle is 4 times the mass of a proton, and its charge is 2 times the charge of a proton. A beta particle is an electron. It originates in the nucleus and moves very fast. The mass and charge of a beta particle is equivalent to the mass and charge of an electron. Gamma rays are electromagnetic radiations. Their wavelengths are shorter than those of X-rays. Let's summarize. Radioactivity can be defined as the self-disintegrating, spontaneous activity in the form of radiations emitted by some unstable nuclei. Radioactivity is exhibited by heavier elements with atomic number greater than 83. Alpha, beta, and gamma are radioactive radiations.